Today we're going to go over ECM motor troubleshooting. We're going to go over troubleshooting the 3 ECM motors that we have in our carrier furnaces today. The 3 motors we have are the FCT, the fixed speed constant torque. That's going to be in our Comfort series products. We have the VCT, which is the variable speed constant torque. That will be in all of our Performance series products. And the VCA, which is the variable speed constant airflow ECM. That will be in all of the Infinity tier products. So in general ECM overview, basically an ECM motor is an electronically commutated motor. There are 2 parts to all ECM motors. You have the motor itself, and then you have the ECM module, which is on top of the, sometimes they're one piece like this picture is showing. The other times is the module can be separated and replaced by itself. So these are the 3 ECM motors that we have in our furnaces today. I'll bring up the pointer here. So this is the fixed speed constant torque. This will be in all the Comfort series furnaces. So like your 58 SB0s, single stage 80%ers, single stage 90%ers will have this furnace in that, which is the fixed speed constant torque. Industry kind of refers it to as the X13 motor. It's basically a 5-speed tap motor. Moving up to our Performance series ECM, this is the variable speed constant torque. This motor has hundreds of speeds programmed into the motor that is set up via dip switches on the furnace and sent to with a pulse width modulation signal. This allows a much greater flexibility between installations to meet desired airflow. We have our variable speed constant airflow ECM. Now this ECM here is a true variable speed motor, and what that means is this motor will react and changes to static pressure to deliver constant airflow. So as, for example, your air filter starts to build up and plug, this motor will increase its speed to deliver the constant airflow required. And this will be found in all the Infinity series products. So ECM motor troubleshooting basics. Basically what you want to have is the installation manual or service manual for the furnace. You're going to need a high quality multimeter. And also when you're dealing with the variable speed constant airflow, the Infinity series product, it is recommended to have the TechInspect Pro. The TechMate Pro, which is made by Gentech, and that helps troubleshoot that motor. So we're going to begin with the fixed speed constant airflow. Again, this is the X13 style motor. It's one of the easiest motors to troubleshoot out of the 3. This motor has 5 speed taps that are programmed into the motor, and those are sent via a 24-volt signal. So first thing we want to do is confirm the 120-volt signal to the blower motor. This is done from terminals BL1 and neutral. All ECM motors will have 120 volts or 240 volts if they're a fan coil sent to them constantly. So that's your first check always, is determine you have the power voltage. So you check for 120 on BL1 and neutral. Okay, we have that. The second thing we would check is to see if we are getting our output voltage. So whether there's a heating demand or a cooling demand, you should have 24-volt outputs from common to whatever the output is. So for example, if you have a cooling call and the motor is not operating, to troubleshoot that motor, you would first confirm you have 120 volts, and then you would put a call for cooling on. You should be able to hear the relay click, and you should check with your motor, your meter between common and cooling and read 24 volts. If you have 24 volts going to that motor and it's not coming on, that is a failed motor. If you have 0 volts off these terminals, then you need to look into the board. You can also double check, put a heating call on. Sometimes only one of these taps will go bad, but if you don't have voltage coming off of your control taps, then that is a failed circuit board. Okay, so moving on to the variable speed constant torque, our pulse with modulation motor. Now, again, there's a little bit more to this, but at the same concept, it's relatively simple to troubleshoot. So there are two electrical connections on the ECM module. You're going to have your line voltage, which is going to be your constant 120 volts. So again, that is where you start when you're dealing with motor troubleshooting. Confirm I have power voltage to the motor. Okay. The second, when you're dealing with this motor, is the control voltage is what's called pulse with modulation. So it's a DC voltage that's sent to that motor to tell it to run at a certain frequency. And that voltage changes depending on where you set the dip switches on the circuit board to change the airflow. So the easiest way to test this motor is using the component self-test that is built into the circuit board. That way we're not guessing at what the output voltage is, and it gives us a relatively small range of voltage. So on the motor you will see that you have a brown and yellow wire going to that motor. That's going to be your control voltage, your DC voltage. The yellow lead is the torque command. The brown lead is your 15 volts constant voltage, your common basically. So troubleshooting the blower motor, again on this board, this is where you would test for your incoming voltage. You have your L1 bar here, so you're going to have like your L1, your transformer, and then also your blower. So make sure you're on the correct one for the blower and neutral. Once that is verified, you're going to verify 24 volts between R and common. Okay, so our board is good currently, and now we're going to go and test the command voltage. So the PWM signals varies with the requested airflow. We're going to use the component self-test to check the motor. So on our Performance Series furnaces, along with the Infinity, SW1-6 is the component self-test. Self-test will run the motor at 50% PWM signal, so approximately 6 to 8 volts DC between yellow and common. We want to check with the harness connected. That's important on this motor. Don't disconnect the harness and try to check from the board because you won't get the correct voltage. The harness has to be connected, and you'll put your leads into the back of the harness going to the motor. Alright, here's a great visual on testing the PWM motor. So the first thing you're going to do is power on the unit and have no command. So the unit is in standby. We have our yellow amber light. At that time, we're first going to confirm our 120 volts to the motor off these terminals here. Once that's confirmed, now we're going to check our 15 volts constant to DC voltage to the motor. So we can see here off our 11-pin harness going to the motor, out of this Molex harness here, we have two wires. We have our yellow and brown. The brown wire going to the motor should be always a constant 15 volts DC. So to test your leads going to the motor, you're going to always have one of your electrical leads on common of the thermostat terminal. The next, you're going to test your brown, and it should be 15 volts DC. Now it's a nominal voltage, so it may be a little bit more, a little bit less. So once that's connected, and we've tested 15 volts, we can move on to the next step. The next step would be testing the command voltage. So how we do that is, again, we're going to test in standby on your signal wire, which is the yellow wire. And again, we can see his lead is on common from the thermostat strip and piggybacked into the yellow wire going to the motor. In standby, that voltage range should be between 10 and 12 volts DC. We can see on this furnace it's 10.44 volts DC. Now what we're going to do is send a command to this motor using the component self-test. So we can see SW1-6 is TST, which is the test mode. Once you put that switch into the on position, the first thing it's going to do is send a command to the blower. It'll go through the inducer motor, your igniter, and then it'll energize the blower motor. At that time, you should see the voltage change on your signal wire. So you keep your leads in here. We see we have our 10 to 12 volts DC on our signal wire, which is the yellow wire. We turned SW1-6 to the on position, which is the component self-test. So first your inducer motor is going to come on, your igniter is going to glow, and then your blower motor is going to get commanded to run. It's going to send a 50% signal to run that motor, and that range will be anywhere from 6 to 8 volts DC. So what you're looking for on the yellow wire is a change in voltage. Okay, and we can see here, once the blower was commanded to run, this voltage dropped from 10 volts to 6 volts DC. So that tells us right there that the circuit board is perfectly fine. It's doing exactly what it's supposed to do, and that motor should be operating. If that motor is not operating, then that would signal we have a failed motor or module. Both the FCT and VCT are one-piece motors where you would replace the entire thing. Okay, so moving on to our Infinity Series motor, which is the variable speed constant airflow. This one is a bit harder to troubleshoot because it uses a specific to carrier serial communication from the board to the motor. So a lot of times what you're left doing is making sure the motor is good as far as electrically good between windings and the ground. And with the TechMate Pro, you're able to put a 24 volt command to that motor and run the motor. Again, confirming that your motor is okay. If you get into a point where you have to troubleshoot and determine if the board is sending the proper signals to the wire, to the motor module, then that is where you would get into the MN7 service manual. This is a pretty detailed troubleshooting process to go through, so I always recommend if you are in that situation, you need to have the service manual present and walk through it. I can always email that to you. If you have an HVAC Partners account or the Carrier Service Tech app, you can download it from there. So here's like a visual of the housing for the Infinity system. We can see that this motor has an actual N-bell module. So with this motor, you're able to change the module if just the module were to have failed, saving in the cost for repair. This Molex plug right here off the board, that is going to be your command and serial communication from the board to the motor, and then you have your high voltage inputs as well. So again, first thing when you're troubleshooting, confirm you have your 120 volts to the motor. Second would be to go through troubleshooting your communication, which would be done through the Carrier Service Tech app with the MN7 troubleshooting guide. If for some reason you don't have access to that, you can use the accessory tool, which is the TechMate Pro made by Gentech, and that will basically send a 24 volt signal and run that motor at full speed. So this is a visual of what the TechInspect Pro looks like. Really all you're doing to this is you're getting 24 volts from your board, and then you are inputting that to the motor, and it's going to send a 24 volt signal to the correct taps and run that motor at full speed. This will basically give you a go, no go on the motor. So you would connect to your common and R on the board, and then you're going to put your 4-pin motor module connector to the motor. You'll turn the TechInspect on, and it will run that motor at full speed. So for instance, if you come up to a call and the motor's not running, and you have a code 41 blower motor fault, and you reset the equipment, you put a command for the blower to come on, and the motor does nothing. That one's usually the hard one to troubleshoot. You know, when you come up to these Infinity furnaces, and if it has a code 41 blower motor fault, and you reset the equipment and you put a command on, and always look at the motor and the wheel and see what it's doing. If that wheel comes on and it rocks back and forth, and then shuts off and you get a code 41, 9 times out of 10 that is going to be a failed module, which you can disconnect and inspect that part. If you come up to the equipment and the motor does absolutely nothing and you get a code 41 fault, you can take the Tech Inspect Pro, hook it up, and run that motor. That will tell you that that motor is okay, and you may be dealing with a board issue. But before you condemn the board, you need to go through the troubleshooting manual on testing the communication. Some things to note on the ECM modules. So on your Infinity, you can actually see here on the motor it's imprinted, but if you have a jumper on 1 and 2, it's your 120 volt motor. If there's no jumper, that's a 240 volt motor, so that would be like on your fan coils. So when you're condemning a module or motor, you always want to disconnect them and confirm that the motor itself is in good condition. So this is an example of the module disconnected from the motor. In this module, you're going to have, you know, your capacitors, everything along there. This little green chip here, resistor, usually is what fails. This will blow out and you can smell it electrically or visually see that. That right there will tell you, okay, I got a failed module. You also, even if you can see that the module has failed, you want to confirm that the motor is okay. It's very easy to do. You disconnect the module and you're going to test the windings of the motor. Always wait 5 minutes after shutting power off for these capacitors to discharge before you start disconnecting the module. So the first thing you're going to do is test each winding to ground and make sure there's no continuity to ground. So you take your meter, you set it to resistance continuity, and you go to each lead to ground. You should have OL, it should be open. There should be no resistance to ground. Okay, so that first step is good. The second step we're going to do is test between each winding between themselves. So this is a 3-phase DC motor, so each winding should be equal to each other, plus or minus 10%. So this right here is a great visual of testing the motor. We're going winding to winding, 4.9, 4.9, 5.1. That right there confirms that is a good motor electrically. So hopefully you got something out of this. There is a great ECM troubleshooting training module available on My Learning Center on HVAC Partners. So highly recommend you go on there and take some of the training modules to get a little bit more out of this. Thank you.